So we're dealing with series, and the question we keep asking ourselves is whether a series converges or diverges. Now, it turns out that there are a lot of different tests we can do to find out whether or not a series converges or diverges. And because there's a lot of tests that we can run, this is why most calculus students find this series stuff a little difficult. They don't know which test to use. They don't know how to tell if the series converges or diverges, and they just give up. But it's okay. We're going to start with the divergence test, and we're going to make sure it makes sense. So we are going to work with the divergence test. All right, now, what does this mean? What exactly is the divergence test? Well, the divergence test tells us that if the limit as n approaches infinity, and we're experts at our limits, right, of some a sub n, right, so this is a summation we're going to be doing, does not equal 0, then, let's look at this, then we'll write our little summation notation, n equals 1 to infinity, of a sub n will diverge. So our divergence test, as given by the name, tests for divergence. Now here's something that needs to be made absolutely clear. If our limit does not equal 0, then our series will diverge, okay? However, let's say our limit does equal 0, right? That does not guarantee that that it won't diverge, right? You might see, all right, it doesn't equal 0, then that means it diverges. If it does equal 0, well, then it must converge. That's not guaranteed, and that's why we have all these different tests, because if we fail this divergence test, we still don't have enough information to draw a conclusion. We'll have to go on and do another test. So that's the important thing to remember. All we're checking is if our series passes the test. That's the important thing. So we're going to see, and if in this case, if it does pass the test, then our limit will not equal 0, okay? So that's just one thing that's really important to clarify. Now let's put this into practice, right? So say we have a sum, right? And we are going to go from n equals 1 to infinity. And what is our sum going to be? Well, it can be anything we want. So how about we say n to the fourth minus 3n squared over, what do we want to say, 5n to the fourth plus 2. Okay. So what's another way to write this, right? We can write this in our limit notation. We could say, what is the limit as n approaches infinity of our a sub n, right? Of our n to the fourth minus 3n squared over 5n to the fourth. Now, we know how to do this by this point. If we're onto series, we know how to find limits as they approach infinity, because we're going to look at our highest degrees, right? We're going to look at our n to the fourths here, because as n gets gigantic, as n gets closer and closer to infinity, these other terms, 3n squared and plus 2, they're not going to matter as much. They're going to be dwarfed compared to 5n to the fourth and n to the fourth. So we're only looking at those, and then we know that as we're approaching infinity, all we have to do is look at the coefficients in front of our highest degrees. So n to the fourth, our coefficient is going to be 1, and then 5n to the fourth, our coefficient is 5. So we have 1 over 5, and so we know that this limit as n approaches infinity is going to be equal to 1/5, right? This is just a quick review of our limit as n approaches infinity. So we know this, right? And let's see. If our limit as n approaches infinity of a sub n does not equal 0, then our series will diverge. And what do you know? Last I checked, 1/5 does not equal 0. So we have passed the divergence test, and we know that our function right here, let's do it in this color, we know that this series right here, which we will denote a sub n, since the limit of that as n approaches infinity does not equal 0, we can say that it diverges. Now again, I just would like to reiterate this. Say we got that it did equal 0, right? Then we are going to fail the conditions of our test, but that does not guarantee that our series will converge, right? It could very well still diverge, and that will be explained in our later test videos. All that's important is if we can evaluate our solution if we pass the test. And in this case, we passed because the limit was not equal to 0, and so we found that it diverges. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.